In this question, it is given that let set M is the set of all ordered pairs which satisfy this condition where R is greater than 0. Consider the geometric progression an equal to 1 by 2 to the power n minus 1, where n is equal to 1, 2, 3 and so on. Let S0 is equal to 0 and for n greater than equal to 1, let Sn denote the sum of first n terms of this progression for n greater than equal to 1. Let Cn denotes the circle with Sn-1, 0 and radius an, and Dn denotes the circle with center Sn-1, Sn-1 and radius an. This is question number 13, which is the first question of this paragraph. In this question, he is saying, consider M with R equal to 1025 by 513. Let K be the number of all those circles Cn that are inside M. Let L be the maximum number of circles among these K circles such that no two circles intersect. Then you have to find the correct choice. It is clear that set M denote the set of all those points which satisfy this condition, means which lie inside the circle with center 0, 0 and radius R. All the points lying inside or on the boundary will lie in the set M. And now let us start defining the circles. He says Cn denote the circle with center Sn-1, 0 and radius an. That is for the circle C1, center will be S0, 0, radius will be A1. For the circle C2, center will be S1, 0 and radius A2. Similarly, for the circle C3, center will be S2, 0 and radius A3. As it is given that S0 equals 0, it means this point will become 0, 0. And it is also given that let Sn denote the sum of first n terms of this progression, whose terms are these. That is, I can say Sn is equal to A1 plus A2 up to An, and A1 is clearly 1, A2 is 1 by 2 and An is 1 by 2 to the power n minus 1. That is, this is equal to 1 minus 1 by 2 to the power n upon 1 minus 1 by 2. That is equal to 2 minus 1 by 2 to the power n minus 1. That is, I can say S1 is equal to 2 minus 1, that is 1. Therefore, this becomes 1, 0. And S2 means 2 minus 1 by 2 to the power 1. Therefore, S2 becomes 2 minus 1 by 2, that is 3 by 2. Or we can also say S2 means 1 plus 1 by 2. 1 plus 1 by 2, 0. I'm writing in this way because it will be more simple for you to understand if I write in this way. I can write 3 by 2, but this will be more simple to understand if I write in this way. Similarly, C4 will become having center S3, 0, that is equal to 1 plus 1 by 2 plus 1 by 2 square, 0 and radius A4. Because an is 1 by 2 to the power n minus 1. Hence a1 will be 1, a2 will be 1 by 2, a3 will be 1 by 4, a4 will be 1 by 8. By now you must have got the picture of all the circles Cn in mind. Still, for more clarity, I am drawing all the circles Cn. First circle C1 has center 0, 0 and radius 1. Therefore, it is 0, 0 and radius 1. Second circle C2 has center 1, 0 and radius 1 by 2. Because this length is 1, therefore, second circle will have center here and radius 1 by 2 means this is the second circle and radius of this is 1 by 2. C3 is a circle with center 1 plus 1 by 2 and radius 1 by 4. 1 plus 1 by 2 is, this is the position 1 plus 1 by 2 and radius is 1 by 4. As the radius of this is 1 by 2, radius 1 by 4 means this circle, the radius of this is half of the radius of this, radius of this is half of the radius of this. For more clarity, I am drawing the circle C4 also. C4 has center 1 plus 1 by 2 plus 1 by 4. It is 1, it is 1 by 2, it is 1 by 4. Therefore, for circle C4, this is the center and radius is 1 by 8. That is, again radius is half of this. That is, this is circle C1, this is C2, this is C3 and this is C4 and so on. And now to draw the circle of set M, we will be drawing a circle with center 0, 0 and radius 1025 by 513. That is, this is the circle of set M and radius of this circle is 1025 by 513. Recall that this point was having x coordinate 1. This is the point having x coordinate 1 plus 1 by 2. This is the point having x coordinate 1 plus 1 by 2 plus 1 by 4. And this is the point having x coordinate 1 plus 1 by 2 plus 1 by 4 plus 1 by 8. Now he is asking, let K be the number of all those circles Cn that are inside M and let L be the maximum possible number of circles among these K circles such that no two circles intersect. Then you have to find the correct choice. That is, to find the value of K, we have to find how many circles of this type are lying in this circle. And the number of circles lying in this bigger circle is K. And after finding the value of K, you have to find the value of L. L means maximum number of circles among all these K circles which do not intersect each other. You can see very easily every alternate circle is not intersecting the previous one. That is, I mean to say, this is not intersecting this one and this will not intersect the circle with this point as center and so on. Therefore, first of all, let us find the value of K. It is clear that for the circle C4, the extreme point has x coordinate 1 plus 1 by 2 plus 1 by 4 plus 1 by 8. That is for circle Cn. The extreme point will have coordinate 1 plus 1 by 2 plus 1 by 4 plus 1 by 8 up to 1 by 2 to the power n minus 1. And let n be the number of circles which lie inside the circle or at the most touch this circle. For that situation, for this to happen, the value of this should be less than 1025 by 513. That is 1 minus 1 by 2 to the power n upon 1 minus 1 by 2 is less than 1025 by 513. That is 2 minus 1 by 2 to the power n minus 1 is less than 1025 by 513. That is, I can say 2 minus 1025 by 513 is less than 1 by 2 to the power n minus 1. Note that we have to find the maximum value of n satisfying this. That is, I get 1 by 513 is less than 1 by 2 to the power n minus 1. That is, I can say 2 to the power n minus 1 is less than 513. It is clear that the maximum value of n for which this is less than this is when n minus 1 is equal to 9. That is, n becomes 10. That is, I mean to say 10 is the maximum value of n which will satisfy this. That is, in case radius of m is this much, then 10 circles are possible which will lie inside the circle m. That is, the value of k becomes 10. And now the maximum number of circles which do not intersect each other will automatically become 5, because first, third, fifth, seventh and ninth circle will not cut each other. Therefore, the value of L becomes 5. And once we have got the value of K as 10 and L as 5, it's clear that choice D is correct. And now next question of this paragraph is, in this paragraph he is discussing about the circles Dn, and Dn denote the circle with center Sn-1, Sn-1 and radius An. As previously I had discussed about the circle Cn, now I will be discussing similarly about the circles Dn. It's given that Dn denotes the circle with center Sn-1, Sn-1. Therefore, for the circle D1, center will be 0, 0, because for the circle D1, center will be S0, S0, and S0 equal to 0 is given to us. And radius of this circle is An, and An is 1 by 2 to the power n minus 1, that is 1. For the circle D2, as I had found, Sn is equal to 2 minus 1 by 2 to the power n minus 1, that is Sn is equal to 2 minus 1 by 2 to the power n minus 1. And because for D2, center is S1, S1, and the value of S1 is 1, therefore it will be 1, 1, and radius of this will be 1 by 2 to the power n minus 1, means 1 by 2. For the circle D3, because S2 is 2 minus 1 by 2, that is 3 by 2. Therefore, center can be written as 3 by 2, 3 by 2, or we can also say 1 plus 1 by 2, 1 plus 1 by 2, and radius of this is 1 by 4. Similarly for D4, center is 1 plus 1 by 2 plus 1 by 4, 1 plus 1 by 2 plus 1 by 4, and radius 1 by 8, and so on. And now let us start drawing the circle. First circle has center 0, 0 and radius 1. It is 0, 0 and radius is 1. And for the circle D2, center is 1, 1 and radius is 1 by 2. Note that 1, 1 will be this point, and D2 is a circle with center this and radius half, that is radius is half of it. This is S1 comma S1. This is a circle D1. This is a circle D2. For the circle D3, center is this. This is 1, 1, and because radius is 1 by 2 here, therefore this will be the point having center S2, S2, that is 3 by 2 comma 3 by 2. Note that radius of this is 1 by 2, 1 by 2. This point is 3 by 2 comma 3 by 2. And D2 will be the circle with center 3 by 2, 3 by 2 and radius half of it, that is this. And because we have to find the number of circles lying inside a circle M whose radius is this much, that is suppose we can draw n circles inside this circle, then the extreme point of nth circle should lie inside the circle. If Dn is the last circle which can be drawn inside this circle, for this circle to lie completely inside, this point should lie inside the circle. It's clear that for Dn, center will be Sn minus 1 comma Sn minus 1, and the value of Sn is this. Therefore, the center of nth circle will be 2 minus 1 by 2 to the power n minus 2 comma 2 minus 1 by 2 to the power n minus 2. And because for the nth circle radius is an and an is 1 by 2 to the power n minus 1, say this point is A and this point is B. And for the extreme point to lie inside the circle, the length OB should be less than radius of circle M, that is this, that is 2 to the power 199 minus 1 into root 2 upon 2 to the power 198. And it is clear that OB is OA plus AB. This should be less than and because the x coordinate y coordinate of the point A are these, and we know that if some point has x coordinate y coordinate alpha alpha, then this distance is alpha root 2. Therefore, OA will become root 2 into 2 minus 1 by 2 to the power n minus 2 plus AB. Radius of another circle is this much. That is 1 by 2 to the power n minus 1. It should be less than 2 to the power 199 minus 1 into root 2 upon 2 to the power 198. And dividing by root 2, I get 2 minus 1 by 2 to the power n minus 2 plus 1 by root 2 into 2 to the power n minus 1 less than 2 to the power 199 minus 1 upon 2 to the power 198. That is, I get 2 minus 1 by 2 to the power n minus 2 plus 1 by root 2 into 2 to the power n minus 1 is less than 2 minus 1 by 2 to the power 198. This 2 will get cancelled. And that is, I get 1 by 2 to the power n minus 2 minus 1 by root 2 into 2 to the power n minus 1 greater than 1 by 2 to the power 198. Now multiplying by 2 to the power n minus 2, I get 1 minus 1 by root 2 into 2 is greater than 2 to the power n minus 200. It's clear that the maximum value of n satisfying this is 199.